Okay, so the next thing on the list is the kind of like the second part of it. Like we've gone over the introduction, now it's time for files. So one prominent feature of an IDE is built-in system for managing files. Both the elementary functions like moving, renaming, and deleting, and ones more specific to development like compiling and checking syntax, it may also be useful to have operations on sets of files, such as finding files of a certain extension or size or searching files for specific patterns. In this first article, I'll explore some useful ways to use tools that will be familiar to most GNU Linux users for the purposes of working with sets of files in a project. Using ls is probably one of the first commands an administrator will learn, getting a simple list of the contents of the directory. Most administrators will also know about the -a and -l switches to show all files, including dot files, and to show more detailed data about files and columns respectively. There are other switches to GNU ls which are less frequently used, some of which turn out to be very useful for programming. So like -t for like the last modification, listing them in modification date order. You've got what? Capital X to group by extension, V to naturally sort by version numbers and file names, capital S to sort by file size, and capital R to list files recursively. So you're going to pipe this into a pager. So these are all pretty powerful pretty powerful ways to sort through files with ls, but the other thing that can be very handy in quickly understanding the size of your file, for example, would be to add the /h parameter onto it, or switch, however you want to say it. And basically, all you have to do is go ls-lh, and you get a full listing here. So you can see like, 8.8 megabytes, whereas if I take out the h here, because I'm using exa, that's why it does it the way it does, and it's all colorful. So by default, it would show you more information and shorthand your things so that they're easier to read. But yeah, so since listing text is like anything else, you could, for example, pipe the output of the command into a Vim process. So you could add explanations of what each file is and save it as an inventory file or add it to a README. This kind of stuff can be automated by make with little work, which I'll cover in another article later in the series. Funnily enough, you could get a complete list of files, including relative paths, with no decoration by simply typing find with the dot argument for the current directory, though you may want to pipe it through sort. If you want an ls-l type listing, you can add ls as the action to find results in GNU find. Note that in this case, I have to specify to sort that it should sort by the 11th column of the output, the file name. This is done with the K option. Find has a complex filtering syntax all of its own. The following examples show some of the most useful filters you can apply to retrieve lists of certain files. So like the dot-name and then .c finds names matching a shell style pattern using the iname for case insensitive search. So instead of doing -name, you do -iname, and then it would basically search for all your C files. And then you can do the path, finding files with paths matching a shell style pattern. Use ipath for insensitive, so you're looking for a path name that has test in the name. You've got mtime, find files edited within the last 5 days, so that's what the -5 is. You can use +5 instead to find files edited before 5 days ago. And then find newer, server.c, find files more recently modified than server.c, and then find a -type D, find directories. For files using type F for symbolic links, use type L. So it'll give you like a full readout of the different things you can do with it. So if I go man1 find, I've got all these options that I can go through. So if I find, where is it? Dash type should list our options for file types that we're looking for. Let's see, regex. So you've even got man, that's a pretty powerful tool to enable you to look through and find different options for using your tools that a lot of IDEs include. So here you've got like block and then character, directory, named pipe, regular file, a symbolic link, a socket, a door. So doors for Solaris stuff. So sockets would basically be like also your like network sockets. So like NPD creates a socket and then so on and so forth. So you've got those whole host of options to go through. Note in particular that all of these can be combined. For example, to find C source files edited in the last 2 days. By default, the action find takes for search results is simply to list them on standard output. There are several other useful actions. So like -ls provides the ls style listing, delete matching files, and then exec run an arbitrary command line on each file, replacing the brackets with the appropriate file name and terminated by that. You can use plus as a terminating character instead if you want to put all the results on one invocation of the command line. One trick I find myself using often is using find to generate lists of files that I then edit in vertically split Vim windows. Earlier versions of Unix as IDE suggested the use of xargs, which find results. In most cases, this should not really be necessary, and it's more robust to handle file names with white space. So then searching files, more often than attributes of a set of files, however, you want to find files based on their contents. And it's no surprise that grep in particular, grep-R is useful here. So this is like recursively searching in a folder. This searches the current directory tree recursively for anything matching some var. So this is what I used heavily when editing those files in the Pocket Crystal project to replace files, find what files were where, and so on. Don't forget the case insensitive flag either, since by default grep works with fixed case. So you'd add a -I, capital R, and then some var, and so on. Also, you can print a list of files that match without printing the matches themselves with grep-L. Yeah. So listing files can be helpful because it's like, okay, I just need to know the file and then I can use sed on something. If you write scripts or batch jobs using the output above, use a while loop with read to handle spaces and other characters and file names. And so you can go through the file, read file, and so on. If you're using version control for your project, this often includes metadata in the .svn, and so you can exclude various files or remove them. So this dealt with easily enough by excluding using -v anything matching appropriate fixed string. Some versions grep include exclude and exclude dir options, which may be tidier. So you can do that as well, and this is very handy. With all this said, there's a very popular alternative to grep called ACK, which excludes this sort of stuff for you by default. It also allows you to use Perl-compatible regular expression, which are a favorite for many programmers. It has a lot of utilities. It's generally useful for working with source code, so while there's nothing wrong with good old grep, since you know it will always be there, you can install ACK. I highly recommend it. There's a Debian package called ACK-grep. Being a Perl script, it's otherwise very simple to install. Unix purists might be displeased with my even mentioning a relatively new Perl script alternative to classic grep, but I don't believe that Unix philosophy or using Unix as an IDE is dependent on sticking to the same classic tools when alternatives with the same spirit that solve new problems are available. So again, this comes down to using the best tools. You've got a lot of tools out of the box in a Unix system that allow you to do a lot of powerful things, but sometimes you can find tools that may work a little bit better. But understanding how to use those like bare bones tools that are default with it can be very powerful, because it means your knowledge is portable and that you still know how to work with a tool that is there in your environment. And then it makes it easier to get work done, because not every environment's going to be the same depending on your line of work in IT. File metadata, the file tool gives you a one-line summary of what kind of tool you're looking at based on its extension, headers, and other cues. This is very handy with find when examining a set of unfamiliar files. So you can use find.exec file and so on, plus directory. As a final tip for this section, I'd suggest learning a bit about pattern matching and brace expansion in Bash, which you can do in earlier post-entitled Bash shell expansion. All of the above makes the classic Unix shell into a pretty powerful means of managing files and programming projects. Ergo, like mkdir for making directories, rm for removing files, and rm-R for removing directories recursively, and so on. There's a lot to work with in the command line, and these are some of the more involved tools, which makes sense why you're not going to go over the very basic stuff, but you go over like the file finding and things that people may not be as familiar with, and I can understand. I've used some of these tools to work with files in various formats. Now, he mentions the file metadata stuff. So if I go back to, I don't need that anymore. If I go back to the LF window that I've used previously, you can see that I've got the file type classification here. And this is what file basically does for you. So if I go into the .config lfrc, I can go down. Where did my preview go? Oh wait, it's not here. So if I go down to the bottom, what the default does, so you can see battercat, I will output the file where possible. I should probably have a better implementation for battercat here. But then I've also got file dereference brief, and it adds a brief summary of what the file type is and gives you an idea of what it is. So just like that output, and of course it echoes file type classification right there. So if I go back to LF, I can go into my ROMs directory, for example, and it'll output what type of thing it is, and so on. And in some cases, I can get a header from the file as well with information about it, depending on the ROM that is being put into it. So like right here, you can see the capabilities they have in the ROM itself. And this is kind of some of the power that you have with the command line and the basic tools that actually in many ways, many times come pre-installed on your system. And in some cases, even come with more portable implementations of the Unix tools like BusyBox for embedded systems. If you enjoyed the video, then like, comment, subscribe, feed the algorithm, boost the video up, share this video with your friends. If you found it informative or you just want to chat, I've got plenty of places in the description. Discord, Guilded, and what have you. Check those out, and I will see you guys in the next one.